Hello everyone, welcome to my YouTube channel. In my last video, I have discussed about some important points related to symmetric and skew symmetric matrices, and I also have discussed about the definition of hermitian and skew hermitian matrix. Today I will discuss some important points related to hermitian and skew hermitian matrices. So let A and B both are hermitian matrix of order n cross n. Then A plus A conjugated transpose of A, comma A into conjugated transpose of A, and A conjugated transpose of A multiplied with A, all are hermitian matrix. Now I will prove this. It is given that A and B are hermitian matrices. Then conjugated transpose of A will be equals to A, and conjugated transpose of B will be equals to B. Now we want to prove that A plus A transpose, conjugated transpose of A, is equal, whole transpose is equals to A plus A transpose. We have to show this. In order to show this, firstly we approach from left side. So A plus conjugated transpose of A whole transpose. We can express it like it will distribute over each matrix, so it becomes conjugated transpose of A plus conjugated transpose of A whole transpose. Now this becomes A only, so this can be expressed like, so we got that if we take the conjugated transpose of this term, we get again this term. So this implies what? By the definition of hermitian matrix, A plus conjugated transpose of A whole transpose is equals to conjugated transpose of A plus A, and this implies that A plus conjugated transpose of A is a hermitian matrix. Similarly, you can show that the product of A conjugated transpose into A conjugated transpose into A all are hermitian matrix. Now I am going to discuss the second point, and that is as follows. If A is a hermitian matrix, then Ka, that is the scalar multiple of A, where K is any scalar, and A to the power n, that is the integral power of a hermitian matrix, is also a hermitian matrix. And you can show it by yourself. It is very easy to show. Just apply the definition of hermitian matrix over these matrices. So, and hermitian matrix is also called self-adjoint matrix. Sometimes it also denotes, sometimes it also expresses in the form of self-adjoint matrix. Then we should understand that it is talking about the definition of hermitian matrix. So now I am going to discuss some important points related to the skew hermitian matrices. Now we will discuss about some important points of skew hermitian matrices. So the first point is as follows. Every real symmetric matrix is hermitian. We know that the definition of real symmetric matrix is as, that is, A transpose is equals to A. A square matrix is said to be a real symmetric matrix if A transpose is equals to A. In order to show that this matrix A is hermitian, we have to take the conjugate as well, because by the definition of hermitian matrix, the conjugated transpose of A should be equals to A for hermitian matrix. So let's take conjugate on both sides. As we know, this is real symmetric matrix. So if it is real, its conjugate must be equals to itself. So we can express it like A transpose conjugate is equals to A, because A is a real symmetric matrix, so A bar must be equals to A. So from here what can we say? That A conjugated transpose of A is equals to A, and this implies that A is hermitian matrix. So in this way we can say that every real symmetric matrix is an hermitian matrix. Now I am going to discuss the second property of the skew Hermitian matrices. So the next property is as follows. If A is any matrix of order n cross n, any skew symmetric matrix of order n cross n, since we are talking about skew Hermitian, then A minus conjugated transpose of A is always skew Hermitian. So A is skew Hermitian, then A minus A conjugated transpose of A will always be skew Hermitian. Let's prove it. Let B is equals to A minus conjugated transpose of A. In order to show that this matrix is skew Hermitian, we have to show that conjugated transpose of B is equals to minus B. So let's take conjugates on both sides. So this becomes conjugated transpose of B, A minus conjugated transpose of A, whole conjugated transpose. Now it will distribute over each matrix. So this becomes this can be written as A. So this can be expressed like if I take minus commons outside, then this can be expressed as A minus conjugated transpose of A, and this is equals to B. So from here what we get that conjugated transpose of B is equals to minus B, and this is the definition of skew Hermitian matrix, that if the conjugated transpose of a matrix becomes equals to its negative, then we say that B is skew Hermitian. Implies A minus conjugated transpose of A is skew Hermitian. Similarly, you can show that the sum of two skew symmetric matrices, the difference of two skew symmetric matrices are also skew Hermitian. In each case, we are talking about skew Hermitian. That is, the sum of two skew Hermitian matrices, the difference of two skew Hermitian matrices are also skew Hermitian, provided that they should exist. That is, A plus B and A minus B must exist. Now, if we talk about a scalar multiple of a skew Hermitian matrix, that will also be a skew Hermitian matrix. That is, if A is skew Hermitian, then Ka, the scalar multiple of skew Hermitian matrix, is also a skew Hermitian matrix. And you can show it very easily. Now I am going to, so let's prove it. In order to prove that it is skew Hermitian, we will take the conjugated transpose of this matrix. Now two cases arises, that K is any scalar, then it may be real or complex. If K is real, then the conjugated transpose of K will be K always, and the conjugated transpose of A. Now since A is skew Hermitian, then the conjugated transpose of A becomes minus A. So this can be expressed as minus Ka. Now what we are getting from here, where K is coming from R, where K is a real scalar. So if K is a real scalar, then the conjugated, the scalar multiple of skew Hermitian matrix will be again a skew Hermitian matrix. Now what about complexes? Now if I take K from set of complex number, that is, if I take K equal to iota belonging to the set of complex numbers, this is also scalar, and I multiply it with the conjugated transpose, and I'll take the conjugated transpose of IA, that is the scalar multiple of A, where scalar is coming from the set of complex numbers. So this can be expressed as the conjugated transpose of I into conjugated transpose of A. Now, if we take the transpose, there is no effect on I. But as we take the conjugate, I becomes minus I, and the conjugated transpose of A becomes minus A, since A is a skew Hermitian. So this becomes IA. This is the definition of Hermitian matrix, not a skew Hermitian matrix. So in this case, when we take K from the set of complex numbers, in this case skew Hermitian IA, that is the Ka, scalar multiple of matrix A, will not be skew Hermitian. So this case is not possible. This is possible only when we choose the scalar from the set of reals. So I hope that this property of the skew Hermitian matrices is clear to all of you. And if you are liking my content, please subscribe my channel. Thank you.